College of Engineering is building its first satellite. This satellite will be a 10-centimeter square CubeSat that will be launched into low Earth orbit with its primary mission objectives of collecting and transmitting images from 2 onboard cameras back to Earth and establishing a presence of Marquette University in space. In addition, this will be the first satellite deployed in the state of Wisconsin.
The CubeSat allows for a truly multidisciplinary experience. Electrical aspects include the communications, power, control, and camera payload systems. Mechanically, the satellite requires a lightweight and durable structure. Computer experience is needed to implement the onboard software. Senior design students participating in this project join with the established MUSE team, or Marquette University Spacecraft Engineering, to create this feat of engineering.
MUSE was established in 2011 by Dr. Bishop, the current Dean of Engineering, and a group of passionate students interested in space. The group has grown from 10 to 36 students, which now currently range in majors from engineering and computer science to anthropology and finance.
MUSE team is currently working on 3 different initiatives. One is the design of the CubeSat itself. The second is testing a CubeSat on a weather balloon, which will achieve altitudes close to actual low Earth orbit. This will enable us to test the functionality of our communication systems while simulating a CubeSat in orbit.
The third initiative is testing the CubeSat in a reduced gravity aircraft, aka the Vomit Comet. This will help us test the CubeSat in zero gravity situations. So far, the team has developed prototypes for each subsystem.
We have a prototype 3D model of the satellite structure. We also have preliminary work on the communication system that will go into the satellite.
We have partially completed the software for the visible light camera and have ordered a thermal imaging camera.
The team has determined what hardware will be needed for our ground-based mission control.
The first revisions of the power board and flight computer have been built and tested, and the software has been designed.
In addition to the components of the CubeSat, the team has been working on simulations that will tell us how it will behave in space.
You may be wondering how students of varying backgrounds work on this satellite. We've broken down the CubeSat into key components so that everyone's talents can be utilized.
Although this picture looks overwhelming, it's actually quite simple. The hexagons represent a different subsystem of the CubeSat. The lines that connect them show how they're all related.
The structure subsystem is developing the skeleton of the satellite. Much like a human skeleton, this structure houses and supports all the different internal components of the CubeSat.
The electrical power subsystem is the heart of the CubeSat. It takes solar power from the sun and delivers it to the rest of the CubeSat.
The payload subsystem is developing the eyes of the CubeSat. This includes the thermal and visible light cameras and the software that runs them.
The command and data handling subsystem is the brain and the soul of the CubeSat. This includes the flight computer itself, as well as the software that runs on it. The communications subsystem is the mouth and ears of the CubeSat. The onboard radio will transmit images and status messages. It will also listen in for commands from mission control.
It's for you.
Hold on, I gotta take this.
The ground station subsystem, otherwise known as mission control, is the mother of the CubeSat. The ground station will track the CubeSat's orbit and send and receive messages.
The simulation subsystem is crucial to launch. Simulations help the team understand how the CubeSat will act in space. We are very excited that you've decided to join us on this once-in-a-lifetime project with MUSE and launching a CubeSat into space.